Okay, let's go ahead and get started. Once again, thank you everyone for attending. Today's webinar is Lessons from the Trenches, Moving to Snowflake, brought to you by Datasource Consulting and EXL Company. Our speakers today, we've got two of them for you. We have Eric Linneman, our Cloud Competency Director, and Jerry Perez, our Data Integration Competency Director. And I'll introduce them both in more detail here shortly, but first let me tell you a little bit about Datasource Consulting and how and why we know about this topic. We are a pure-play enterprise data management, modern data architecture, and decision intelligence consulting firm. In 2016, we were acquired by EXL Service as part of their analytics arm, so we're really excited to now be able to offer the end-to-end solutions from managing enterprise data to providing the deeper business insight. And as far as how we deliver, we divide our services into two categories. We have our strategic work in data governance, vendor tool evaluation, data virtualization, and program establishment. And then we have the implementation arm with the engineers, the architects who work with the internal client teams to deliver on the recommendations we make through the strategy work. And that includes architecture, cloud and BI, decision intelligence, data quality, and MDM. So let me introduce our guest speakers, Eric and Jerry. Eric, our Cloud Competency Director, has over 20 years of successful enterprise consulting as a database engineer and cloud deployment and IT project manager, and he has deep experience with multiple platforms as well as technical and organizational leadership and modernization. Eric has won several awards for his excellent customer engagement, performance, and leadership. And Jerry, our Data Integration Competency Director, brings over 14 years of experience in the data integration and ETL space, actively leading our data integration competency and also specializing in custom development. Jerry works closely with data warehouse architects on tasks like source system analysis and data profiling, and he's also architected, designed, and developed ETL and provided support and solutions for error handling processes and scheduling strategies. So we're really excited to have both of them here today. Thank you both. And our topic for today on moving to Snowflake is exciting because there are so many companies now, of course, moving their data warehouse to the cloud, and Snowflake is growing very quickly. So it's great to hear the hands-on experience working with them and what we've learned from facilitating these migrations. And so again, thank you all for joining. I do want to mention that if you have any questions, you can utilize the questions field at the bottom of your GoToWebinar panel. We'll address those in the last Q&A during those last 15 minutes, 10-15 minutes or so of the presentation. So with that, I will hand it off to Eric.
Thank you, Allison. I apologize for my voice. I picked the worst possible week in the year to get sick, and please bear with me. We'll see how long I can hold out. So we're going to go through a couple of things today, talking about modern data platform and really where Snowflake and the architecture and how to do this right comes into play. Jerry, can you go to the next slide? So Datasource is a partner with Snowflake, and we've been doing work with them for a little over a year, delivering solutions across a number of industries, global companies, Fortune 100, and really doing work from greenfield to integrated analytic data warehouses so our customers can see a 360-degree view of their business, their vendors, their suppliers, their customers, and really their environment. Together, we've been delivering some pretty innovative solutions, and really the best part is that both Snowflake and Datasource are learning some of the new ways that our customers are leveraging this technology to improvise and improve their business. And it is making a change for a lot of folks. Next slide, please. So Snowflake is a data warehouse as a service, and this is sort of a new business model. It's a new technology and a new offering in the marketplace. There really is nobody who has anything that competes with them on this level. But a critical part of understanding when you're going to a cloud model and the different types of services and deployments that are available is understanding really what your role is, what the vendor does, what the cost basis is, and really how to leverage this going forward. This is a diagram that shows kind of the roles and responsibilities for the different models. And if you look at on the far right, the services side, that's really where Snowflake comes into play. So they're managing everything on the back end. They're managing the optimization. They're managing the backup and recovery. And so really the focus from a business perspective comes into getting your data into the data warehouse, understanding it, driving value out of it. And that changes the way we implement and the way that we design, because you're really refining your cost that you spend on this and the responsibilities more toward a business value rather than purely IT and infrastructure operations. You can take the folks that you've got who work in that area and leverage their existing skills and knowledge because they know your business, they know the data, they know the customers, they know how this is being worked, and use that to transform their skills and their utilization to a higher business value roles. So it's not really a product that displaces people. It's really a product that engages and brings greater value to the business. And we're going to walk through a couple of the ways that that does. But this is a game changer in that traditionally to deploy a data warehouse, you had to buy some pretty expensive licensing, some really expensive hardware, very, very expensive and difficult to manage storage. And all of that goes away. So Snowflake is now in the marketplace where from a small customer to these large global companies, there's a solution that leverages the technology and architecture that Snowflake has, and it opens up data warehousing to companies that never had that availability before. Jerry, next slide. So Datasource has developed this process that we've put together, and it's our methodology for getting to the cloud. And we've been doing this for a couple of years and very successful with our customers, and we've refined this and learned the lessons and have this methodology that we use to move people to the cloud. It really comes down to, are you ready to move to the cloud? What's the right path to get to the cloud? Prioritize your functions and have a holistic roadmap of how you're going to get to the cloud. And then prepare to operate in the cloud, optimize your operations, and really adapt and grow the solution that you're putting in the cloud, aligning with business value and capabilities rather than simply IT spend. Jerry, the next slide. So really what we're talking about here is a modern data platform. And this is an architecture we put together for a customer that was leveraging Snowflake and leveraging a number of different AWS technologies. And you can see it looks like a lot of different things. It looks like a lot of integration, a lot of capability, different products, different things that you have to bolt together. But the nice part about the cloud is this really separates you from vendor lock-in. Stuff that we could never do before. Say, for instance, you're an Oracle customer and you're on an Oracle platform and you want to wrap in a brand new BI tool, or you want to bring in new sources of data. Maybe some of those are semi-structured or some of those are unstructured data or streaming data. Very difficult in an old model, but really easy to do and in a coherent way in a new model. This architecture leverages the cloud for scale, for stability, and reliability, because we're using the cloud vendors to manage the back end, to manage the services and make them available and redundant where needed for availability. And really our focus now is on how do we leverage the tools? How do we refine the data? How do we clean it? How do we get maximum value out of it? How do we bring new tools and new capabilities in place, such as R, some of the more advanced analytic capabilities, some of the deep learning, machine learning type of things that are coming along without having to break our entire architecture. And what this does is it gives us the ability to integrate new data, new tools, new processes, and consume the information that we've got in a much better way. And it also changes the game because now we're on a utility-based model. So we can scale up and scale down along with seasonality we have, and we can directly tie that cost that we've got from the cloud to the business value that we've got there. The other thing, it leverages a couple of key components in the cloud, and that is you integrate through standards. All of these tools and technologies have built-in standards for security, access, manageability, and scale, and all can be accessed through APIs in a number of languages. We now have the capability to do schema on read, and we'll talk about that a little more and where that comes into play with Snowflake and makes things a lot easier than what we've been able to do before. And the critical component is we're bringing process to the data. We're no longer locking in our data with a specific process or a specific vendor. Go to the next slide. So let's take a look at the total value. And this is a study that Forrester did, published earlier this year, and really looked at what's the value of going to the cloud, and then specifically they focused in on the Snowflake value for their customers. And I'm not going to read off all these things, but there's cost savings in storage, compute, labor. We're driving database management costs to a minimum by leveraging the vendor's scale and capability and built-in expertise they've got. We're flexible. Since we're on a utility model, we pay for what we use. We can scale up and scale down based on demand. And time to market. So we can have an environment ready and good to go literally in days rather than months, and a long procurement cycle going forward. I'm going to give you an example. In-house, we put together a cloud model similar to this to train our own folks on Talend. We had 10 people trained over 2 weeks using Talend, using AWS as their architecture, and our total cloud costs were $236. So it is changing the way that businesses look at training, businesses look at prototyping, businesses look at deployment and alignment with business change. Can we go to the next slide? So if we look at it, what this does is it frees developer time to drive business value rather than focusing on stability and availability of the systems. It removes costs for upgrades, since that's part of the managed service you buy. I can remember spending weekends at a customer where we planned for months to do upgrades, and all the coordination and orchestration and the various items that have to happen. If that's built into your model and that's built into your development process, this becomes seamless in moving forward. And then Snowflake also brings to the table a new capability for sharing data, and you can share that data with customers and also share the cost of that data with customers built into the product. So you don't have to build your own expensive billing and complex cost management process on top. And then really, through Snowflake, we're driving the database management cost down as low as we can. We're shifting that cost from operations and processes like keep the lights on, which is pretty familiar with most folks in a traditional IT environment. We're shifting those costs into really driving insight and value out of the data. So what this does is it gives you the capability to grow your people, raise the value of IT as an organization within the company to the business, and enable new capabilities that we simply were blocked from doing before. Jerry, next slide. So this is the study, and you can go download this. This is available to everyone. These are some hardline numbers that actually our customers and Snowflake has been able to produce through a number of different companies. And you can see these companies down below. They span from really big, billions in revenue, down to customers that are managing, thousands of customers rather than millions. But the cost value and the return on investment are very clear and very quick. And it really is a transformational product that brings a lot of change. I would urge you to go grab that Forrester study. Snowflake publishes this. It's available to everyone. And it goes into tremendous detail on where the cost savings came from and how they were derived. Can we go to the next slide? Jerry's going to walk us through in detail some of the work that was done in moving data in and how we can transform from legacy or even other cloud vendors' MPP environments into Snowflake. But critical to understanding this is the architecture that Snowflake brings. They bring a multi-cluster shared data. And by using the cloud and the object model in the cloud, we separate storage from cloud services and the compute layer. So we can spin up compute as needed, isolated from other compute clusters, so it's unaffected as far as performance, leveraging the same data and adding some additional values such as time travel, zero-cost cloning, data sharing. The APIs and the interfaces are all published and well available that can work with pretty much any tool that is out there. And the benefit from this is we've now unlocked our data from a vendor lock-in. So we can use these tools and technologies that are provided, use Snowflake to drive compute, push data to other technologies, separate from other efforts that are going on. So We get away from some of the issues that we've seen with some other MPPs where we have to shift workload from ingest to compute. We have to do vacuuming. We have to do a lot of maintenance on that. That all goes away. This is just a data warehouse as a service that we leverage and move forward. Jerry, next slide. We mentioned earlier ETL versus ELT. And both of these architectures have place in a modern data platform. Traditionally, what we've done is we've taken data, we've scrubbed it, we've normalized it, we've managed it, and brought it into a data warehouse in a very strict structure. It's schema on write. So we know that data, we know where it's going to go. But what do you do if you want to add in some streaming data, or you want to add in some semi-structured, such as Parquet or Avro, that may be coming from different places and may vary over time? And that's where the more modern ELT approach comes, where we bring data from various sources, bring it into a data lake, and then we use a schema on read to bring it into our data warehouse. And we can adapt that over time so we're not having to rebuild and break things. The nice part about Snowflake is it makes it very easy because they have built-in native capability to handle semi-structured data, such as data that comes out of Salesforce or Twitter, data that's being built on Parquet or Avro or XML files. And we're seeing this more and more. Avro's coming out of Kafka streams, Parquet coming from Spark. We're seeing this from machine logs that are coming along. And the infrastructure and the architecture is built to handle that from day one. We don't have to make changes. So my last slide is the next one, and we'll wrap this up quickly because you really want to see what Jerry's put together. And these are some of the best practices we've learned for working with data warehouses and specifically Snowflake. When you go into this, know your data, knowing also that your data will change over time, and so you build your design to be flexible enough. You need to know what information you've got, where it's coming from, how you consume that data, and then also over time track how that changes and align your schema, align your consumption, align your design, and align the resources you dedicate to that. You need to plan how to age your data, and there are capabilities in the cloud that make this very easy to do, along with archival and very quick recovery. So leverage that, understand what your data lifecycle policy is, and use the technology that's available in the cloud. And then have a security policy, a corporate security policy that is comprehensive, detailed, and ubiquitous across everything. Snowflake's got a great advantage here because there is no way to store unsecured data within Snowflake. So we're already a step ahead on that security model, but align with the tools capability and build your design with security from the start. And then again, taking into account one of the things that the cloud brings, so treat your data and your process differently. Over time, your process will change. Over time, your data will change. But with this new model where we separate the two, we're no longer having to go back and break things down and rebuild those. We can now bring in best of practice tools. We can now bring in new data. For instance, if your company is going through a merger and acquisition phase, we can now bring this data in using MDM tools to unify it and resolve key mismatches. We can use data quality to make sure that our quality is unique and uniform across all the different sources and that we've got good quality in there. We can leverage the scale of the cloud to handle these kind of workloads for seasonality, like in retail right now. And we have capabilities that we simply didn't have before. So understand these things as you plan out your trip to a cloud data warehouse. And that's all I've got. Thank you very much.
Hello, everyone. This portion of the presentation is more from a delivery and implementation perspective. And, these are the things that we'll cover. Some of the reasons for moving to the cloud, a roadmap. We'll be doing a simple demo to kind of give you a look at how to migrate some data into Snowflake, recommended best practices and lessons learned, as well as some closing thoughts. Why are some of our clients moving to the cloud or migrating their databases to the cloud? There's a laundry list of these, and these are some of the ones that we hear more often. They want to reduce overhead. They want to review their entire architecture. This is something that we've seen before with on-premise migrations. A lot of times, some clients wanted to go from one data platform to another, purely so that they could assess and audit their environment and identify what needs to be left behind. And on-demand performance is actually something that the cloud, as well as Snowflake, brings, which is actually very heavily utilized by our clients. And in some cases, we've actually heard digital transformation, because there's a lot of clients wanting to go to the cloud. The cloud is a hot topic, and they want to move on. So in those cases, we basically assess the environment and provide some support and knowledge to our clients about taking on such a solution. At a very, very high level, this is kind of an architecture that we're seeing more often. The data warehouses as well as data platforms are no longer multi-tiered. They basically get all consolidated into this area that we call the lake, or the landing area. And a lot of work actually gets done on that area. We're seeing more and more of a hybrid integrated process within an environment that includes cloud and on-premise systems, as well as different strategies for moving data and implementation, such as batch and streaming. And we're actually seeing ETL and pushdown. So pushdown is what a lot of people refer to as ELT. And ETL, it's still a very critical part of the ingestion process of loading the data into the cloud. From a roadmap standpoint, we actually have some high-level components and tasks that we generally follow while we're doing an implementation of a data platform migration. We look at connections. These are generally very different. Sometimes, in the old world, we would be focused on ODBC drivers and proprietary drivers from tools. And now we're going towards a more open source environment where we're seeing a lot of JDBC drivers and other types of connectivity. Security, their security is handled very differently on the cloud environments as it used to be done on the traditional environments. And integration processes such as ETL and ELT have actually become the norm of managing and handling the data on that end. Objects that we generally see that need to be taken a very close look at are scripts, tables, views, stored procedures, functions, and sequences. Chances are that your environment, if it's still running in a traditional data warehouse environment or data platform, has a lot of these, and these are things that must be audited and verified to make sure that we can have a fairly good transition to the cloud. Some of the tasks that we provide as we're and implement as we're actually migrating to the cloud, we provide a lot of auditing and validation. The data movement is very important. I think a lot of times clients tend to focus on migrating to the cloud, not realizing that the migration of the data itself may be just one task, just making sure that everything that it's running in the environment runs as it used to on the new data platform on the cloud runs the same way, as well as reporting. Reporting, sometimes we get lucky and we can just repoint to new sources to get that reporting, but in a lot of cases, we have to validate and maybe refactor some of those reports to make sure that they take advantage of the latest technology on the cloud. The approach that we use from an implementation and delivery side is very iterative. Assessing and collecting assets are within the environment is something that is ongoing through this process. Visualization is very important. I think when we go to the cloud, where there are so many features and applications and tools that are used to handle and wrangle your data in your data platform, it is very often forgotten that we need to kind of provide a way of visualizing how this data is moving and what's happening to it as it goes across the environment. And with that, we actually implement and work with notification and validation processes. Generally, these are automated processes. We want to make sure that as things are running or failing, that we have a clear understanding of why, and if we don't, just to at least have a place to start the investigation. And then we implement iteratively through this process as we go from asset to asset, migrating it to the cloud. Some considerations to while you're actually venturing on this journey of moving to the cloud in Snowflake. MPP databases are often selected as part of the cloud migration. We have a lot of MPP databases out there from Microsoft and Amazon. Snowflake is also an MPP database, and some of these databases may not actually have the same features as your traditional databases on-premise do. Things such as sequences, store procedures, and functions may not be there, or may be there in a different form that may require some additional scripting or development to get them to work the same way. Performance will decrease when we're loading and manipulating small payloads of data. So back again to that hybrid model, we recommend that the large data and the long overhaul of this data gets done on the cloud, but things such as from the operational side, such as ABC, auditing, and consolidation of the processes that are executing should continue to be maintained as part of our relational environment, because it does include many queries and manipulation of very small sets of data at a row level. And for MPP databases, this actually is a bit of a performance killer. Updates are expensive. Manipulating merges and provides a lot better performance in this MPP environment. Also, the process of migration, the ETL. We used to be able to do everything with one ETL tool, or at least most of the work with just one ETL tool in the traditional data warehouse environments. But as we're going to the cloud, we're starting to realize that there's actually two different methodologies that need to be used. One of them is basically the ingestion process. We want to make sure that we make that as efficient as possible. Snowflake provides a tool called the Snowflake bulk loader that allows us to securely transfer that data very quickly from on-premise to the cloud. And in addition, for those other data sets that may not be able to use the Snowflake bulk loader, we suggest that data be compressed and sorted so that we can take advantage of that compression, as well as use an ETL auditing process to ensure that we know and we're keeping track of all the data that is getting loaded. The second methodology goes around ELT, or push-down optimization, for these environments. It is very costly to actually push data to the cloud, then pull it back to do some transformation, and then push the transformed data back into the cloud. So ELT, or push-down, what that allows is for us to be able to generate queries or manipulate the code necessary for all of these transformations to occur on the database side, so that it actually doesn't leave the data doesn't leave the domain. In the traditional way, we would actually have an ETL tool that would serve as a data broker, and it actually would sit in the middle, having the data going through it so that it can transform it as it's actually pushing it to the target. But that's very inefficient as we're actually building these new modern data platforms. Testing strategies for data migrations, this is critical. The data integration process work can be very challenging. Identifying all the sources and the modifications that need to be done, that can be very challenging, but testing is key. We want to make sure that we actually have as many test strategies as possible as we're migrating to the cloud, because we want to make sure that the business continuity works just as it did before. So here is a list of some of the strategies that we often use and tend to see. We have comparing one database to another on a one-to-one direct way. We can compare a set of source data that has been migrated to the target database in order to facilitate some of that comparison. Often, depending on the data types and how the data is hosted on the source and the target, those sort of testing that testing may be very difficult because it doesn't reside on the same environment, and also can be very slow. By the time you're actually running a test, the data has changed on your source and it actually looks different. It becomes more difficult to run those tests. End-to-end run testing, that's actually something that goes hand in hand with the integration testing. For the integration testing, we definitely ensure that all of the processes are run and that they're actually able to execute in the sequence that we want to. Along the way, we want to be able that we test and validate the data that gets transformed or moved from those processes. And one of the other strategies that we've seen and that we've used in the past is to have both environments in a production-like state. What that means is that you may have your source database environment as well as your target database environment running under one scheduler or a clone of that schedule, so that basically they both run at the same time. And after the nightly load, for example, we can actually test out the data. So now we're going to be moving on to a demo. This will give you an idea of what it takes to migrate and test some of the data as we're going from one source platform, data platform, to a target one. In this case, we'll be using a Redshift database, which is actually something that we're seeing nowadays. We're not only seeing migrations to the cloud from an on-premise environment, but we're also seeing cloud-to-cloud migrations, which is pretty interesting as we've come to find out. We'll be moving some of this data from Redshift to Snowflake, and then we'll be showcasing one of the types of testing that we do on this data set. Okay, so this is a live demo. You may see my screen flicker a little bit, but that's just me switching windows here. Okay, so first let's go ahead and open the Redshift web console as well as the Snowflake web console. For those of you who are familiar with AWS or Snowflake, this may actually seem very familiar. Okay, so here we have our Redshift on the left, and we have our Snowflake on the right. So on the left, we see a database named DSC Demo RS, and it has a series of schemas. Some of these schemas are actually populated and created out of the box when you create the cluster for this database. And these ones with the prefix of DW are actually the ones that hold our data warehouse data that we want to migrate to Snowflake. On the Snowflake side, we see that we have one database that we called DSC Demo SF. And when we drill into it, there's nothing. There are no objects. This is where we're going to be holding the objects and the schemas that we're going to be migrating from the Redshift side. Now, even though both of these consoles are available on the web, we generally tend to use some form of an IDE to make sure that basically we can connect to both database systems and that we have one interface where we can do all of our work. Okay, so over here I've created connections for both Redshift and Snowflake. Let me go ahead and expand those. Okay, so we see on our Redshift side our DSC Demo RS schema, as well, database, as well as all the DW schemas from the data warehouse. And then on the Snowflake side, we see our DSC Demo SF database. Now, one thing that I'd like you to note is that everything on the Redshift side is lowercase. I didn't do anything to make it that way. This is by default how it comes out of the box from the Redshift side. However, on the Snowflake side, everything is uppercase. Now, this is really not a big challenge or different or a big challenge to deal with, except when you're actually working with reporting and ETL tools. So let me demonstrate how this actually can actually work and become a disadvantage depending on what kind of tools for reporting and ETL you're using. Okay, so let's just try to create a schema on the Snowflake side. Choose the Snowflake connection and run that. Okay, so we successfully created a schema. Let me go ahead and refresh. Now, what we're seeing here is that I actually created a schema named test in lowercase. However, in Snowflake, it actually created that same schema in uppercase. Now, that's really not, doesn't seem like a big issue, but it could be. Let me go ahead and create a table, a sample table in that schema. And we'll just go ahead and put field 1, set up the variable character, and a second one as an integer, and let's create that table. Sorry, forgot to put the schema there. So now when we drill into our schema, we see that a table has been created. Now, once again, I created a table in lowercase and fields in lowercase, but everything, my table name, as well as the columns has been set up to uppercase. Now, it's been, it's something that we actually work with, dealt with in the past, that the client may actually want to make sure that the target schema, target tables, and fields actually match the source one. Now, there is a way of doing that with Snowflake, and that is by actually applying these bookends or actually surrounding the field with double quotes. We can actually do that on the table name. We can do that in the table fields. And let's go ahead and drop and recreate that table. And now we see that basically that table is, the name is in lowercase, as well as the columns. Now the challenge with this is that by default, Snowflake expects those names to be in uppercase. So if I actually try to select everything from this table, I'm going to get an error because, as you can see here, actually Snowflake converted my query into uppercase. So I have to make sure that my query contains that table name in double quotes. Now I can see my result set, and of course it's empty. I don't have any data there. Now this applies as well to data fields. Now this may not seem like a big issue, with the exception that there might be some ETL tools and reporting tools that will basically write the query with just simple text and not basically apply this double quotes surrounding the names. And that's something to actually take into consideration as you're moving into Snowflake and other MPP databases. Each one of these databases actually has their own little way of handling some of these things, and all of it can be worked out, but in some cases it could actually cause some headaches depending on the tools that are in your stack currently. Okay, so with that, let me go ahead and clean this up a little bit. Drop the schema. Okay, so let's go ahead and migrate a schema from Redshift to Snowflake. Now, over the years, we've actually worked with this challenge many times, and we've actually been able to create some accelerators and tools to allow us to very quickly, or at least speed up the process of the things that we need to do in order to do this repetitive tasks. So we created a series of accelerators that we use in our engagements to basically speed up these solutions. Now we're going to go ahead and migrate a schema. We know that our target schema is going to be Snowflake, and our source schema, our source database, is going to be Redshift. Okay, so let me go ahead and put in my credentials to connect to the Redshift database. Now we can use a remote agent that we've developed for on-premise, but in this case, because we're going from cloud to cloud, there's no need to actually use a remote agent. So once we validate the connection and the connection has been valid, copy paste problem here. Okay, so we successfully connected to Redshift, and now we're going to be provided with a list of schemas that we can select to be migrated. In this case, we'll go ahead and just select the DW integration one. And once we select that, we actually have a list of all the tables, views, objects that are in there. And in this case, I just want to go ahead and select all of them to generate the DDL necessary to migrate these schemas. So what the application is doing right now is it's going through each one of those objects in Redshift, and it's going through a conversion process where it's generating the DDL to the based on the target database, which in this case is Snowflake. Once it gets generated, we have a file that we can download. It's right here. Okay, so we have a script for each one of these tables, as well as we provide a script for all of the tables in case you just want to run this in bulk. So let's just go ahead and run all of it. So The schema generator will generate all the constraints for the tables. You know, in MPP databases, constraints are not enforced, but we encourage that those constraints are at least created, because they actually provide a wealth of information when we're trying to do things like lineage and data quality on those data sets. So let's just go ahead and run this script. So it's actually going through each one of the objects that were in the source and that were generated here individually. Okay, almost there. Okay, so that was successfully created. So let me go to my Redshift or my Snowflake database instance, refresh, and I should see a brand new schema there with all these tables that were generated. Now you'll see that everything is in uppercase. That's because the tool, we've actually configured it to make sure that everything is the default. But we could very well configure the tool to basically make sure that the casing, the naming of those source objects is the same in the target database. Okay, great. So now that we've actually migrated a schema, we can then go ahead and move some data. So let's see here, collapse to Snowflake, and we migrated the schema, DW integration. These are tables that are in the source, and what we're going to be doing, both of these data platforms, Redshift as well as Snowflake, are in the AWS environment. So what we're going to be doing is we're going to grab a table from Redshift, and we're going to unload that table into an S3 bucket from the AWS environment. Now, I already have a script here that does such a task. I want to unload everything from DW integration INT material, and I want to store it into this bucket here, to this folder called transfer, and as this file. We provide credentials, the delimiter for the file. This is going to be a flat file, so I want it to be delimited by a pipe. I want to treat nulls as escape nulls. I want to allow overwrite in case we have to run this more than once. I want just one version of this file. We want to escape the file. And also there's this statement here called parallel off. Now parallel off, what this parameter does is it basically makes sure that the file that gets created on the S3 bucket is just one single file, like holding all of the data. If I did not have this statement, it would actually chunk or split the file into a numerous set of files, and that's actually, you know, very useful in a lot of situations. But I know that this file is very small, and I just want to make sure that I just contain it into one object in S3. So let me go ahead and open my S3 web console. And here we have a bucket, DSC demo RS bucket. We have a folder named transfer, and we're going to be unloading the data from that file into an S3 object here. So let me make sure that I'm connected to Redshift, run this query. And it has successfully unloaded the file. So when I refresh, I can see that the file is here. It's about 10.7 megabytes. And now that it's here, I'm ready to grab the data from here and transfer it to my to the Snowflake counterpart table for this one. So I do have another script for this one. This is a script for loading S3 to Snowflake. So basically, we want to use the copy command from the into the DW integration in INT material table in Snowflake. Actually, let me change my connection here to Snowflake. From the location that I saved my file in the S3 bucket, provide credentials as well as a file format. So it's a delimited file. It contains a pipe delimiter, and the nulls are being treated as escape nulls. So go ahead and execute that. And the data has been migrated to Snowflake. So if I go now to my Snowflake table and INT material, and I preview the data, I can see that the data is now here, loaded into my Snowflake database. Now that we migrated the data, what we want to make sure is that we validate the data, that we compare the data that we loaded from Redshift to the Snowflake equivalent. So we have another accelerator that we generally use in this sort of projects. To generate test documentation. Now, what this will do is actually generate an Excel document that we can use as a deliverable to our clients to basically provide the things that we tested and the results that we tested in a way that it can just be used as a single component for this particular object. So our source environment is Amazon Redshift. So once again, I gotta log into Redshift here real quick. Okay, no need for a remote agent. Let's validate that connection. We are connected. So once again, we're provided with a list of schemas, and we are going to be testing objects from the DW integration schema. And let me sort this. There it is. And we're going to be testing that INT material table that we migrated. Now we get to choose our target environment. In this case, it's Snowflake. So now I have to log into Snowflake. No need for a remote agent. Let me validate that connection. Valid. So now we are presented with a list of schemas that are in that Snowflake database. Now, the reason we have this screen here is because there are times where we can grab that text file that had all the DDL that we generated from Redshift into Snowflake, and we might choose for that for those objects to be in a different schema. And we just want to make sure that we provide, if that is the case, that we can provide a list of schemas where that object will reside. In this case, the schema resides. The schema names are the same, so it's the same schema on both ends. So this is going through both the source and the target. It's basically generating some queries in a document that will allow us to provide us a deliverable. Okay, so we download the file, we extract it here. It's a data validation file. Okay, so for every object, there will be one Excel document, but there will be 3 files total. These 2 text files basically have some very large queries that would not fit in an Excel cell. So we basically generate a link to those files from within the document. So this is an example report that we generate from that application. These are very simple queries. They're just select counts. But we can just go ahead and copy paste those queries. And this one is a source, it's a Redshift. We get this as the count for that Redshift table. And then we select the Snowflake query. Now both of these queries are actually pretty much identical. So it's not that much of a challenge to generate that. So we have a match. Now, another thing that the tool does is it actually generates tabs with the metadata from both the source and the target objects. So we can see here that this is the metadata or the DDL, the definition for the table INT material from this schema, this database, and the type of database. So it populates that for us automatically, as well as the target. So this is the target definition with all of the same attributes for this document. So now we have this this type of report where we basically are creating a distribution type of test where we actually select things like max, min, length, and other things from each column of the database table. So when I click here, and it actually popped up on my other window right over here. So when I click there, I was provided with this query that I can actually get to select, copy, and paste into my SQL editor. That is a Redshift query, so I gotta make sure I'm connected to Redshift and run that query. Now, this is the results that I copy and paste underneath of this report. So now we can see that per column, all of these things are being tested. Now we have the same from a target perspective. So when I click here on the target, I get this target query. I copy and paste it and run it. And it failed. Oh, I gotta change. This is a Snowflake query. And it doesn't take very long. There we go. We go ahead and copy and paste the result set into that table. And then the final tab is basically an overview of the results that I pasted with a very simple pass-fail, just comparing each one of those values. So if we look at it, most of it appears to have passed. Let's see if there's any failures here. There's a failure right over here. And then we look at the column and we see that it's a timestamp and a timestamp. And it so happens that the precision, I believe this is the precision for both of these values are different in Redshift than they are on Snowflake. So this is really, it failed, but it's really not that much of a failure since we can explain it. We can see another fail over here. This one we could probably explain as well. We can see that the values are not the same because this one has 4 decimal places and this one has 3. Now, this might be an issue with my SQL editor and that the way that it actually brings up the data. So I would start there to try to identify where that failure came from. Okay, so that concludes our demo. And go ahead and start from. Okay, so just want to talk real quick about some of the challenges that we've had with some of these projects. One of them is connector JDBC driver challenges. With those type of challenges, they were generally ETL tool driven. I mean, they were not supporting a particular feature of the JDBC or not correctly. For that, we've always had very great support from Snowflake. As a matter of fact, they have pointed us to their actual development engineers to basically solve some of these issues in a very timely manner. So it's actually worked out for us very well. Other things to actually keep an eye on are double sign integers. A lot of ETL tools may not support this, so it's something to keep in mind. Handling dates with time zone and without time zone. These are things that actually you may already have in your existing environment, and as you're migrating to Snowflake, they may actually look different or may have different precision, and that's something that must be handled. Sysdate, which is a very common function in most databases, is not available, but they do have current date and current timestamp that actually kind of satisfies some of those needs for dates. Duplicate data. The data integration process needs to be enforcing constraints on the data because, like I mentioned before, things such as primary keys and unique keys, they're not really respected in an MPP database or taken into account. Basically, you have to rely on a very solid ETL process to ensure that you can minimize or handle the duplication of data. Testing and precision. That's something that, again, when you have 3 decimal places versus 4 decimal places, the report that comes out of it might be slightly different. So that actually could cause some challenges. But as long as we can actually explain these things, it should be fine to work with. Auto number is another thing that we've actually had challenges with in the past. When you're using the copy command and you have set up a Snowflake database table to contain an auto number or an incremental number for every record that gets inserted. Well, this actually has to happen from the beginning. This has to be assigned when you generate the DDL for that particular table. But when you use the copy command, it basically will grab all of the values from the source and it will put them in your target. And then when you start loading normally into that table, it will start once again at 1, 2, 3, and so on. So that's definitely something to keep in mind. And basically, there are multiple ways of handling that. Database schemas, tables, and fields, and lowercase versus uppercase that we discussed. SQL overrides and view functions. You may have some of those in the source system, or I'm sorry, in the source environment. And these things, this code will have to be reviewed, vetted, and basically changed in some way. Regular expressions is something else that we've actually noticed that may actually be differently handled in one environment to another. Not to say that the regular expression is different in the way that it brings different information. It's just in the way that it needs to be typed, or basically the syntax of the regular expression might be slightly different. Recommended best practices: leverage monitoring and alert mechanisms. Create automation processes whenever you can. It actually allows for a speedy process, because these are, when you're migrating to the cloud, these are things, there are some tasks that you might end up doing more than one, and that become very repetitive and very challenging to get the same results twice if you don't automate, or at least you're going to have a very big challenge trying to validate some of this data on the other end. And then set a freeze window. I think we have this is something that was best practice on premise, and sometimes I don't think it's being taken into account when we actually migrate to the cloud, but it's definitely needed. Closing thoughts: that design of a modern data platform can have hidden costs. Overdoing the on-demand feature can be very expensive. There's so many features and tools in a cloud environment that it can become very difficult to predict with the cost of this environment over time, because it keeps changing. Another thing that we're seeing is that often developers might actually say that not to worry about the performance on a development or a test environment, because it will perform faster in production. And even though that may be true, that could present some challenges on how fast you can provide new enhancements or new development to the production environment in the cloud. Modern data platform migration implementation does not really mean that the traditional methodologies are gone. Best practices and proper architectural design are still needed. And that this is, to consider that, to think that this is not necessary in a cloud environment can be very difficult to and costly over time. In situations where there appears to be meaningful change, many fundamentals are still the same, and data management is no exception. So we just want to make sure that as you're migrating to the cloud, that you realize that there are still a lot of good architectural patterns and design patterns and methodologies that we can port from the on-premise world and then make it work better in this hybrid model.
Okay, Jerry, thank you so much. That was a great presentation. Thank you, Eric, as well. We appreciate you both taking the time to speak today. We actually don't have time for questions. I know everybody probably has another meeting to get to, but thank you, everyone, for attending. And we actually do not have our next webinar scheduled completely set yet, so we will let you know as soon as we do. But I will be sending this recording out to everyone who registered for the webinar, so feel free to look through if you would like to get in touch with either Eric or Jerry. Their contact information is below. And then stay in touch. We will be posting our next webinar as soon as we have the official date. But keep looking at our website. That'll be in January or early February. So thank you again, everyone. Thank you, Eric and Jerry, and Happy New Year to everyone. Thanks.